So, okay, this is our NLP project. Our team name is UniCram. So let's start from question generation. First, we will do some article pre-processing. Here, what we will do is extract all the special name entities, such as person, organization, and then store them into trie structure so that we can ask questions smoothly. So, mainly we have two kinds of questions, binary questions and WH questions. So, for the binary questions, first we will check the first main verb in the action. If the main verb is a model word or be variant, this case is very easy. Like, if the sentence is, I can fly, the question is, can I fly? If there's no model words or be variant, then the case is more complicated. We will check the tense and plurality of the sentence and append do, does, did accordingly, and then generate the questions. Last, we will change the sentence a little bit to make the answer no, because we know that if we just generate question from the original sentence, the answer is always yes. So for the WH question, if there is a person, we will ask who. If there is a location or organization, we will ask where, and so on and so forth. So this is our post-of-speech tagger and NER tagger, so that we can ask questions based on this tree structure.
First, we need to identify the subject and the action from the original sentence. In order to do that, we will look for the structure where VP is a right sibling of MP, just like this, and the corresponding phrases will just be the children of the MP and the VP here. We have three questions to ask: who, when, and where. In order to ask questions, we will first identify the person, location, and date name entities from our NER tree, and then we will compare the NER tree with the syntax tree in order to find out the corresponding phrases that provides for the information that we are asking. In order to ask WH questions, we will first ask who by directly replacing the subject with who, and then in order to ask where and when, we will first remove the corresponding prepositional phrase and then convert the rest of the sentence using the method we mentioned in binary questions, and then we will append the corresponding WH word at the beginning of the sentence. And here are two examples.
Alright, next part is question answering. There are several steps in our answering process. First, we parse the question and text and find one sentence which is most relevant to the question. Then we divide the questions into several categories. Based on their type, we will analyze its grammar and find some potential phrases that give the best answer. We read the text and question, do some pre-processing, and find one sentence with the highest TF-IDF value. When we process the text, we first ignore all the punctuation, stop words, and phrases which do not form a complete sentence. Now, for every sentence in the text, we tokenize it, and we lemmatize every word in the sentence. For questions, based on the first word, we can tell whether this is a WH question, or yes-no question, or other types of questions. For each word in the question, we can calculate its TF-IDF value of every sentence. Term frequency is defined as the number of times this word appears in a sentence divided by the length of the sentence. Inverse document frequency is defined as log of total number of sentences divided by number of sentences that contain this word. When we see a yes-no type of question, we add post-text to every word in the question and extract the key nouns, adjectives, and verbs. We will output no when their synonyms do not exist in the sentence or their antonyms exist in the sentence. Finally, if the target sentence is a negation, we simply negate our previous answer.
For WH questions, we first parse the question grammar and further classify the questions into what to look for in the target answer. For example, a time or an action. Then we extract the relevant words from the question for next step. This classification and keyword extraction can be done by pre-trained question data and a set of common grammar rules. We pattern match the question to the rules, then extract relevant words and phrases with correlated part-of-speech tags to each rule. An example here shows that first we get the WH noun phrase and then separate NP and VP and PP. For when, where, who, why type of questions, the answer type is determined by the WH word alone. For example, when looking for where in the answer, we stick to the following algorithm that picks out all the words with NER tag location, separate into adjacent groups, and for each group we assign a distance score and return the closest one. For what, which, and somehow answers, the answer type is an abstract action or the definition. First, we pattern match key phrases from the question to the answer. Next, we find a particular tag in the grammar tree, like NP or VP. After that, we return the phrase that is determined differently for different grammar rules. The most common one is to return the longest one that does not appear in the question. So for the last type of question answering, our algorithm matches relevant keyword, removes the keyword, and rephrases the rest of the answer sentence. We do so by stripping off stop words in the front or end of the half sentence and some handwritten rules for edge cases. This is our description for the entire question answering framework. Thank you for listening.